Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from Relentless, featuring an interview with Mehul Nariyawala, founder of Matic. He spent 6 years in a basement, rejecting the MVP model and the entire move fast ethos of Silicon Valley. He argues that the robotics industry is fundamentally broken, from its engineering principles to its pricing psychology. His series of heresies offers a radical new way to think about building enduring hardware companies. If some founders told you they spent 6 years in a basement building a vacuum cleaner without shipping a single unit, you would likely call it a failure of execution. But Mehul Nariyawala, the founder of Matic, argues that this wasn't a delay, it was a philosophical necessity to overturn the entire robotics industry. His interview reveals a series of engineering and economic heresies that suggest the way we build, price, and interact with hardware is fundamentally broken. His most jarring engineering stance centers on sensor architecture. The common sense in Silicon Valley is that to make a robot safer and smarter, you add more sensors, lidar, bumpers, cliff sensors, and ultrasonics. To the average engineer, this is redundancy and safety. To Mehul, this is building a Christmas tree of sensors on a machine that is still effectively blind. His logic is that traditional robots are like a person walking around with a blindfold on, using a cane to tap against walls. Adding a better cane or a sensor to detect a cliff doesn't remove the blindfold. It just makes the blind person slightly faster at bumping into things. He argues that the only way to solve robotics is to remove the blindfold entirely through vision-first engineering, using RGB cameras and a visual cortex similar to a human's. He believes that if a robot cannot see and understand context like a human distinguishing a toy from a piece of trash, it isn't intelligent. It's just an automated bumper car. This connects directly to his counterintuitive rule regarding the economics of hardware complexity. The standard engineering dogma is that sensors are cheap commodities. But Mehul introduces a terrifying multiplier. He believes that for every single hardware sensor you add to a device, you must assume the permanent cost of 3 software engineers to maintain it. Behind this calculation is the exponential rise in complexity. Every sensor requires calibration, distinct drivers, supply chain management, and data fusion algorithms. By trying to make the hardware easier with more sensors, companies inadvertently make the software impossible to manage. His heresy is to delete the sensors, delete the LiDAR, and force the software to do the heavy lifting using only cameras. It is a bet that mimics the evolution of biological organisms. Eyes and a brain are efficient. Covering your body in proximity sensors is not. Regarding product development methodology, Mehul shatters the move fast and break things philosophy that dominates the startup world. The standard advice is to ship a minimum viable product, or MVP, immediately to get feedback. He argues that in established hardware categories, the MVP model is a death sentence. His reasoning is based on the minimum lovable product. If you are building something brand new that no one understands, like the first iPhone or the first car, you can ship a rough prototype because there is no baseline. But if you are entering a market that already exists, like vacuums or thermostats, the customer already has a mental model of what good looks like. If you ship a viable product that is worse than their current dumb appliance, they won't iterate with you. They will return it and hate you. He spent 6 years in the dark not to build a product that works, but to build a product that exceeds the emotional baseline of a household appliance. A fascinating psychological insight he shares involves pricing strategy. Everyone assumes pricing is about margin or brand positioning. Mehul argues that pricing is actually about spouse approval. He cites historical data from the Roomba launch and other gadgets to suggest there is a hard psychological wall at $200. Below $200, a purchase is considered toy money. You buy it on impulse, and if it breaks, you don't regret it. Above $200, and certainly above $500, the purchase triggers a family meeting or requires spousal consent. This completely changes the engineering constraints. If you cannot build your robot to be an impulse buy, you are forced into the luxury tier where the device must be a considered purchase like a car. This forces a binary choice. Either build a cheap toy or build a machine that lasts a decade. The middle ground is a graveyard. His ontological stance on robots challenges industry assumptions. He boldly claims that no one actually wants a robot. This defies the sci-fi dream of R2-D2 that every roboticist chases. He believes that the desire for a robot companion is a misnomer. People do not want a buddy, they want a solution to a problem. He points out that we already have R2D2, it's the iPhone. It answers questions and navigates for us. A physical robot in the home should not be a character, it should be an entropy machine. This leads to his operational philosophy of continuous cleaning. He challenges the batch processing model of domestic life. Humans and current appliances operate in batches. We wait for the dishwasher to be full, we wait for the laundry basket to overflow, and we wait for the floor to be filthy before vacuuming. This is efficient for humans, but terrible for maintaining a state of cleanliness. He references the cleaning droids in the movie Passengers, which clean up a spill the second it happens. His logic is that a robot's job is to match the rate of entropy generation in real time. It shouldn't clean your house once a day. It should clean your house continuously, patrolling for new messes so that the concept of cleaning time ceases to exist. Finally, he presents a strategic inversion regarding where to build a business. The common wisdom is to enter exciting, high-growth fields like AI generative art or self-driving cars. Mehul argues that the only defensible business strategy is to pick the most unsexy, tedious categories possible. He points to the Nest thermostat. Years after its launch, it remains the dominant smart thermostat because the work required to build it involves navigating 60 years of archaic HVAC wiring and 800 pages of state-by-state smoke alarm regulations. It is pure drudgery. Because it is so painful and unsexy, big tech companies like Apple and Google internally and agile startups refuse to do the work. He views tedium as the ultimate competitive moat. If you can endure the boredom of solving a problem that makes other engineers quit, you own the market by default. Mehul's approach reveals a consistent principle. He systematically rejects the path of least resistance in favor of the path of highest friction. Whether it is writing your own SLAM algorithms from scratch because open source isn't good enough, or navigating thousands of pages of regulations, he believes that the difficulty is the only thing that validates the opportunity. In a world obsessed with quick software flips and AI wrappers, is there still room for companies willing to spend 6 years in the dark just to get the first dust bag full? If you're interested in the video featured in this episode, click the link below to watch the original.